Welcome back. This is your quick revision for the CBSE Class 10 board, Carbon and its Compounds, in about 12 minutes. Not the whole chapter, just the minimum you need to score. This covers 97% of every CBSE carbon question from the last 5 years. Let's begin. First, the secret of carbon. A carbon atom has 4 electrons in its outer shell. To become stable, it needs 4 more, so it shares 4 electrons with other atoms. Carbon makes 4 bonds, always. We call this tetravalency. And because carbon-carbon bonds are strong, carbon atoms can join with each other in long chains, branches, or rings. We call this catenation. Tetravalency plus catenation is why carbon makes more than 10 million compounds, more than every other element put together. Carbon does not lose or gain electrons, it shares them. This shared pair of electrons between 2 atoms is a covalent bond. Look at methane. 1 carbon shares 1 pair with each of the 4 hydrogens. Single bond, single shared pair. Pure carbon shows up in 3 different forms. Same element, different structures. We call these allotropes. Diamond, every carbon bonded to 4 others in a rigid 3D mesh. That is why it is the hardest natural substance. Graphite, flat layers sliding over each other. Slippery, conducts electricity. And fullerene, 60 carbons in a hollow ball shape, like a football. Compounds of just carbon and hydrogen are called hydrocarbons. If every bond is a single bond, it is saturated. We call these alkanes. If there is at least 1 double or triple bond, it is unsaturated. Double bond, alkene. Triple bond, alkyne. Inside each family, the compounds follow a pattern, a homologous series: methane, ethane, propane, butane. Each step adds 1 carbon and 2 hydrogens. Same family, same chemistry, just a longer chain. That is the magic of the homologous series. Now, replace 1 hydrogen in a hydrocarbon with a small group of atoms, and the whole compound's properties change. That small group is the functional group. A hydroxyl group makes an alcohol. A carboxyl group makes a carboxylic acid. There is also the aldehyde group and the ketone group. The functional group is the active site. Naming follows a 3-step pattern called the IUPAC system. Count the carbons, that gives the root. Meth, eth, prop, but, pent. Pick the family suffix: ane for alkane, ene for alkene, ol for alcohol, OAC acid for carboxylic acid. Add a number prefix if needed. Root plus suffix is the IUPAC name. Ethanol, the alcohol in industrial use. 3 reactions to remember. With sodium, it gives sodium ethoxide and hydrogen gas. With heat and acid, it dehydrates to ethene. And with an oxidizing agent like alkaline potassium permanganate, it oxidizes to ethanoic acid. Ethanoic acid, found in vinegar. 3 properties. It is a weak acid, turns blue litmus red. It reacts with sodium carbonate to give carbon dioxide, and it reacts with ethanol in the presence of sulfuric acid to form an ester, a sweet-smelling compound. This last reaction is called esterification. When a fat reacts with sodium hydroxide, you get soap. The reaction is called saponification. A soap molecule has 2 ends, a long carbon tail that loves grease and a charged head that loves water. In dirty water, soaps form a micelle, tails inward around the grease, heads outward in water, and the grease floats away with the rinse. Now lock them in. A few tricks. Say them with me. 1. Carbon always makes 4 bonds. 4, not 3, not 5. If your structure shows carbon with anything other than 4 bonds, your structure is wrong. 2. Single bonds only, saturated. 1 double or triple bond, unsaturated. The unsaturated ones add things. The saturated ones substitute. 3. 3 families to memorize. Alkanes are saturated with only single bonds. Alkenes have 1 double bond. Alkynes have 1 triple bond. Each double bond costs 2 hydrogens. 4. The suffix tells you the family. Ane for alkane, ene for alkene, yne for alkyne, ol for alcohol, al for aldehyde, 1 for ketone, oic acid for carboxylic acid. 5. The ethanol oxidation chain. Take ethanol, add an oxidizing agent like alkaline potassium permanganate or acidified potassium dichromate, and you get ethanoic acid. Alcohol becomes acid. Remember the oxidizing agent. 6. Esterification. Acid plus alcohol under heat, with concentrated sulfuric acid as the catalyst, gives ester plus water. The acid loses an OH. The alcohol loses an H. Together, they make water and an ester. 7. Soap is two-faced. Tail loves grease, head loves water. Micelle forms, dirt lifts. Hard water? Soap forms scum because calcium and magnesium ions bind it. Detergents work in hard water, that's the difference. Now pause the video, cover the screen. Can you say them from memory? That one act of recall is worth 10 rereads. Before the questions. Here is how to actually solve any carbon problem on the board. 5 steps. The same 5 every time. Step 1. Draw the structure. Always. Every carbon makes 4 bonds. Every hydrogen makes 1. If the formula has 2 carbons, 6 hydrogens, and 1 oxygen, sketch them out and figure out where the oxygen fits. Step 2. Identify the functional group. Hydroxyl is alcohol. Carboxyl is acid. A C double bond O at the end is aldehyde. A C double bond O in the middle is ketone. Circle it. The functional group decides the reaction. Step 3. Name it. Count the longest carbon chain. Pick the root, meth, eth, prop, but. Pick the suffix from the functional group, ol, al, 1, oic acid. Add a number prefix if the group is not on carbon 1. Step 4. Predict the reaction. Saturated? It substitutes. Chlorine replaces a hydrogen. Unsaturated. It adds hydrogen, halogen, or water. Adds across the double bond. Alcohol with sodium. Hydrogen gas. Acid with carbonate. Carbon dioxide. Write the balanced equation. Step 5. Check. Did every carbon end with 4 bonds? Did the equation balance? Same atoms on both sides. Did you write the conditions? Heat, catalyst, concentration. Examiners look for those small details. For MCQs, eliminate. If carbon has more than 4 bonds in any option, that option is wrong. If the formula doesn't match its family pattern, wrong. 2 eliminations usually leave 2. Pick by functional group recognition. For 3 and 5 mark questions, structure your answer. Structural formula. The IUPAC name. Functional group. Reaction with balanced equation. Conditions. 1-line conclusion. That structure is what examiners reward. These are the questions most likely to appear, ranked from years of CBSE papers. 1. How many covalent bonds are in a methane molecule? Carbon needs 4, each hydrogen needs 1. 4 carbon to hydrogen bonds. Each bond is 1 shared pair. 4 bonds total. 2. A 2026 favorite. A compound P with 2 carbons, 6 hydrogens, and 1 oxygen is neutral to litmus and reacts with sodium to give hydrogen gas. What is P? The formula matches either ethanol or dimethyl ether. Ethanol reacts with sodium. Dimethyl ether does not, so P is ethanol. 3. Draw the 2 isomers of butane. The straight chain, N-butane, 4 carbons in a line. The branched one, isobutane, also called 2-methylpropane, 3 carbons with a methyl branch on the middle carbon. Same formula, different structure. 4. Write the equation for esterification of ethanol and ethanoic acid. Ethanoic acid plus ethanol, with concentrated sulfuric acid and heat, gives ethyl ethanoate plus water. The ester has the sweet, fruity smell of nail polish remover. 5. Combustion of ethanol. Ethanol burns in oxygen to give carbon dioxide and water. Saturated hydrocarbons burn with a clean blue flame. Unsaturated ones burn with a sooty yellow flame because of unburnt carbon. 6. Why does soap clean clothes? Each soap molecule has a water-loving head and a grease-loving tail. The tails embed in the oil. The heads stick out into water. The grease gets surrounded, a micelle, and lifts away when you rinse. 7. Why is diamond hard, but graphite soft? Same carbon. Diamond, every atom bonded to 4 others in 3D, no plane to slip. Graphite, atoms in flat layers, only weak forces between layers. Layers slide. Structure decides property. 8. 2 members of the alkene series are ethene and propene. Ethene has 2 carbons. Propene has 3 carbons. They differ by exactly 1 carbon and 2 hydrogens. That difference is what makes a series homologous. 9. Ethene plus hydrogen in the presence of nickel catalyst gives ethane. The double bond opens, 2 hydrogens add, 1 to each carbon. This is an addition reaction. The same trick is used to harden vegetable oils into vanaspati. 10. Methane plus chlorine in sunlight gives chloromethane plus hydrochloric acid. 1 hydrogen is replaced by 1 chlorine. Substitution reaction, typical of saturated hydrocarbons. Continue, and you get di, tri, and tetrachloromethane. 11. Ethanoic acid plus sodium carbonate gives sodium ethanoate plus carbon dioxide and water. The fizz of carbon dioxide coming off is the test. Acids react with carbonates, even weak ones like ethanoic acid. Now your turn. 4 quick questions in the CBSE style. Solve each one yourself, then check your answer. This active recall is how it truly sticks. Question 1. How many isomers are possible for butane? 4 carbons and 10 hydrogens. Draw them. 2. The straight chain N-butane and the branched isobutane. That is it for butane. Question 2. Which gives a sweet smell? Esterification or saponification? Esterification. Acid plus alcohol gives ester, that fruity smell. Saponification gives soap, not perfume. Question 3. Assertion. Graphite conducts electricity. Reason. Each carbon in graphite has a free electron from its 3-bond arrangement. Both true, and the reason correctly explains the assertion. The free 4th electron carries the current. Question 4. Which functional group is in ethanoic acid, and what is its general suffix? The carboxyl group. The suffix is OIC acid, methanoic, ethanoic, propanoic, all carboxylic acids. 60-second mind map. Tetravalency plus catenation, Y carbon. Covalent bond, shared pair. Saturated alkanes substitute. Unsaturated alkenes and alkynes add. Functional group decides chemistry. Ethanol oxidizes to ethanoic acid. Acid plus alcohol gives ester. Fat plus alkali gives soap. Diamond hard, graphite soft, fullerene a ball. Cover the screen and say them all. Then watch this again tomorrow, next week, and the night before the exam. Spaced repetition beats cramming. You have got this. Subscribe, and I'll see you in the next chapter. Periodic classification of elements.